What up, everybody? Another day, another Exercism Elixir problem. Today we're going to jump into another problem. Yesterday was a little bit of a foobar. We did bracket push yesterday, which was supposed to be an easy problem. Let's actually jump into Exercism and take a look. This is the one we did yesterday. Bracket push. Ended up being a very simple solution. The main function that did most of the heavy lifting was just a 20-line little thing here, this is closed function that checked things, which was basically just enum reduce. But I spent about 2 hours trying to complete that one. It was a bit of a joke. But anyway, today, let's hope it gets better. These are me solving the problem live. So I've solved all these other ones. I haven't recorded videos for them, unfortunately, but each one of these that I'm recording daily will be me solving a problem live on screen for you. I hope it's valuable. I'm not really sure exactly what people will get out of it, but in my head, I think that people might be able to see an introduction to the Elixir programming language. If you've never programmed it before, or maybe you're a beginner to the programming language, you're able to see the way that I approach problems in Elixir. If you've never programmed in a functional language, that's going to be something that might help you, because a lot of the approaches to solving problems are going to be slightly different to if you're doing it in a non-functional language. So anyway, let's jump in. If you have any comments or questions, or if I go too fast or too slow, or you'd like me to explain anything that I'm doing, just hit me up in the comments on YouTube or Twitch, or send me a message on Twitter, whatever you like. So today we're doing the RNA transcription problem. And what I'm going to do, instead of reading all this, I'll just get it and we'll read it in the README. So I'm going to download that. Let's jump into VS Code. There's our problem from yesterday, the bracket push. Let's open the one for today, which is RNA transcription. There we go. And first and foremost, as we do with every exercism problem, let's jump straight into the README. RNA transcription. Given a DNA strand, return its RNA complement per RNA transcription. Both DNA and RNA strands are a sequence of nucleotides. The 4 nucleotides in DNA are adenine, cytosine, guanine, and thymine. Shout out to Ronan the Bone Man O'Neill. The 4 nucleotides found in RNA are adenine, cytosine, guanine, and uracil. So that U and the T are different. Given a DNA strand, its transcribed RNA strand is formed by replacing each nucleotide with its complement, G to C, C to G, T to A to U. So this seems like a fairly simple replacement. As always, they have tests that we need to run to confirm that our solution works. So that's the first thing I always do, is just run the test, just to make sure that's all working. Yes, 5 tests, 1 failure. That's because we haven't implemented anything yet. If we let's jump into the test file and just have a look. These are basically the same. So it loads our code and then does xunit to run the tests. The first one is commented out, that tag pending. If we uncomment that, we have no failures, but it's also just excluded all the tests. So that's uncommented. And as you complete your module, you'll uncomment more of those. So this one appears to be a fairly simple one. It seems to be just literally a replace, given we can see here in the test that we're getting a char list in. And let's jump over into our RNA transcription module. So yeah, what we've got here in the spec, as you can see, 2 RNA, and we've got this, which implies that it's a list and then of a char, so a char list. So you can see here in the comment that we're supposed to turn A to U, U to G, A to C. So the first thing I like to do with any of these transcription style ones, I tend to make a map of the transcription. So actually, if we jump back into yesterday's bracket push one, we did that as well, where we had opener to closer map. So basically we wanted the char map of that to that. So basically if I passed in an open square brackets, which is char code 91, I needed something that would spit out the closing brackets as a char code. And so I believe we're going to have to do a similar thing today in our problem. So sorry, this is still in bracket push. Let's jump over to RNA transcription. So we'll say DNA nucleotide to RNA nucleotide map. And so what we want in here is we don't want a char list. So for example, if we jump back to the README, we can see that we've basically got what we want in here, right? So the first item there is the DNA, the second item is the RNA. This is exactly what we want in our map, just so we're not hard coding these. Well, we are hard coding these things, but we want them in a variable that is like a module variable that we don't need to modify. So let's jump back in. We just modify this to be in the form that we expect. And let me just comment these out. All right, so we've got what we need in here, G to C. So what we need to do is work out the char code for capital G. So to do that, I'm going to jump into IEX. What we want is io.inspect. And what we'll do is we'll pass in G, the capital G, and what we want to, if we just print this, it's just going to print G. And what we want is to print the char code. So what we're going to do is pass an option to io.inspect, which is char lists false. And this is actually going to print the integer. So we can see there that it's 71. So if we do that, that's a capital G. And then we want to map that to a capital C. And so let's work out. So what we can do is we can actually do GCTA, and then all we need in addition to that is U. Right, so we've got G, which is 71. C, as we see there, is 67. Let's do C again, which is 67, which maps to G, which is 71, so it's just in reverse. We could probably save some space, but I don't think it's worth it. T, GCT, so if we look down at the bottom, that's 84, which maps to A, which is 65. And then finally A to U, so A is 65, and we'll map that to U, which is 85. Excellent, so we've got our little map there. I'll just increase the space here to make it a little bit nicer to read. So we've got our DNA nucleotide to RNA nucleotide map. And so to RNA, what we're going to do is we're going to get a list of this. So the way that I like to develop these things is to actually do it in IEX before we run the first test, rather than using io.inspect in a test, which is just going to get mixed in with all the test output. I prefer to just develop it in IEX initially and just make sure that everything's working. So actually what we can do is we can just do DNA, and then we can just pass that straight to io.inspect just to see what our function's doing. So the way to get this into IEX is actually in the test file. It's got it up here. So we use code.load file, and then we load our RNA transcription, and that loads the module. So if I paste that down in the terminal, that's going to load the RNA transcription module, and we can access it with RNA transcription to RNA. If we run that, and let's just pass in what it's got here in the example. So if we pass this in, we get the output, right? And that's literally just printing what we've got there in DNA. So what we're going to do is, because we need to remap, and we're going to do a one-to-one map, we're going to use something in enum, right? So enum is your enumerable module. If I pull up enum in dash, let's have a look. There we go, we've got enum, something in there. So we've got enum, we've got all of our functions down there, all, any, etc. As a rule of thumb, if you're doing anything that takes in a list and returns a list of the exact same length, modifying one of each of the items in the list, that's always going to be a map. The functional name for that is a map. So you can use enum.map. You could also do it with reduce, and you could also do it with a for loop. But I think enum.map is the most clear because it's the most standard version of what we've got. And literally all we're doing in our enum.map, if we write the function in here, what that is going to receive is one of the items from the char list. So it's going to get a char as the input to the anonymous function, And all we want to do in there is use our DNA nucleotide to RNA nucleotide map to work out what the RNA nucleotide is going to be. So the RNA nucleotide, and we don't even really need to write that, it's just going to be a map.get, and it'll be the, we need to pass in the map. So we've got our DNA nucleotide to RNA nucleotide map, and we're going to pass in the char, which is the DNA nucleotide, and what it's going to spit out is the RNA nucleotide. So if we reload our code here and then run this again, we're going to get it back out. And if we look at let's look at the comment there, this is actually what we get. UGAC. So we may have actually solved this already. So let's have a look. That's looking all correct to me. I think we may have solved it, and let's test that by actually running the tests. So if I go back here and I run the test, our first test should be working. Let's jump back over to the test module, and we will comment these pending tags, which means that we are now testing them. So previously where it was 4 excluded, now it's 3 excluded. We have 0 failures. As you see here, we've got these passing. Test transcribes guanine to cytosine, cytosine to guanine. So let's comment another line. Okay, let's comment that line, run the tests again. Cool, we have 1 excluded, and let's do the full thing. So all our tests are passing. That was an extremely simple problem that we had there. So we just literally had a map of the char codes. I think probably for some people making this would have been slightly difficult, but if you did the problem yesterday and you're aware that in IEX you can use io.inspect to get the char code for something. So for instance, if I pass this in, right, if I pass that in and then char lists false, that's going to print that as a list of integers, which is going to give you the char code, and that's just an integer to represent what character that is. Yeah, that's literally it. As a bit of fun, let's use some refactoring skills to make this a little bit cleaner. So what I'm going to do is I'll make a little private function that, given a char code, and actually we could just do it like this, for instance. We could just we didn't even need map.get. We could probably do something like this, and 1. Doesn't look as nice to me, to be honest. That's a little bit less readable, but this should still pass the tests. There we go. So I think what might look a little bit nicer is if we have like get RNA for DNA, and then we just pass in, let's call it DNA nucleotide, it's hard to spell, and it will literally just be this, right? And that'll be DNA nucleotide. So all that's doing is that's just doing a lookup in the map to return the RNA nucleotide, and then in enum.map we can just pass a reference to get RNA for DNA, like that, and that just looks a little bit nicer to me rather than having the anonymous function. But honestly, it doesn't really matter. The only reason I'm doing this is because we solved it so quickly. Let's make sure all the tests are still passing. That's still good. Okay, so I think we're done. What I'm going to do is submit this to Exercism submit, and then we've got RNA transcription.exs. Submit that. Boom, very nice. That was a nice quick one. Let's open that in Chrome and take a look. Cool. Well done on solving this exercise. Thank you very much, Exercism. I'm very pleased after the 2 hours that we spent yesterday. I'm very happy that this one was solved so quickly. Cool. There we've got a little solution. And if we go back to the Elixir track, we should see that one ticked off. And yeah, So this nth prime, I've solved that one already as part of the Elixir meetup in Taiwan. But phone number is what we'll do tomorrow. So check back in tomorrow and we'll do another Exercism Elixir problem. This one should go up on YouTube. I have been playing around with the YouTube Live dashboard. There's me talking and that seems to be working. So this one will be up on YouTube for posterity. It will also be up on Twitch so you can watch it later. Thanks so much for watching if you have, and Happy New Year. I'll see you tomorrow.